NASA confirmed it. The moon is leaving Earth at 3.8 centimeters every single year. And in 600 million years, total solar eclipses will be physically impossible. Not rare, not unlikely. Impossible. Every human being alive at that moment will look up at the sky, and the moon will be too small, too far. A disk that no longer fits. A world that no longer covers the sun. And the silence from every major space agency on what follows isn't confusion. It is the sound of scientists who have run the numbers to their logical conclusion and understand exactly what comes next. Because this isn't just about eclipses. The moon doesn't just light the night sky. It holds this planet together. And what we haven't told you yet, what the data buried inside tidal mechanics actually confirms, is that several systems on Earth are already responding to a moon that isn't where it used to be. We'll get to that. But first you need to understand the scale of what has already happened. The moon has drifted 14,000 miles farther from Earth since the dinosaurs went extinct, 66 million years ago. 14,000 miles. Already gone. Already beyond reach. And it is never returning. The physics of tidal locking operate in one direction only. Angular momentum transfers from Earth's rotation to the moon's orbit. And that transaction is permanent, compounding, and irreversible. Every single day the moon exists in our sky, it is stealing a fraction of Earth's spin and converting it into distance. The system has no reverse gear. There is no mechanism anywhere in Newtonian or relativistic physics that returns the moon to where it once was. You are sitting on a planet that is being unwound in real time by the same gravitational force that made it habitable. That is the logic break at the center of this. The moon's recession didn't begin quietly. It began with a catastrophe. 4.5 billion years ago, a Mars-sized body called Theia struck the proto-Earth. The impact was so violent that a section of Earth's mantle was vaporized, blown into space as a superheated cloud of rock vapor and debris. That debris entered orbit. Gravity compressed it. Within roughly 100 million years, it coalesced into the moon. At formation, the moon sat approximately 14,000 miles from Earth's surface. Today it orbits at 239,000 miles. Read that again. The moon formed from Earth's own body, torn from it in the most violent event in this planet's history, and in 4.5 billion years, it has traveled 225,000 miles away from the wound it came from, at 3.8 centimeters per year. That rate is not accelerating, that rate is not decelerating. It is consistent, measurable, and confirmed by laser-ranging experiments that have bounced light off retroreflectors left on the lunar surface by Apollo astronauts since 1969. We have been watching the moon leave for over 50 years, with equipment precise enough to track its motion to the millimeter. And the mechanism is tidal locking. This is the part that fractures the logic entirely. Earth rotates faster than the moon orbits. Because of that rotational mismatch, the tidal bulges that the moon's gravity raises on Earth, deformations of our planet's surface and oceans, sit slightly ahead of the moon in its orbital path. The moon's gravity pulls backward on those bulges. Earth's rotation slows. But by conservation of angular momentum, the energy doesn't vanish. It transfers to the moon. The moon accelerates. An accelerating moon rises to a higher orbit. The same gravitational coupling that stabilized this planet's axial tilt, that regulated the tides, that gave every ocean-dependent species on Earth its biological clock, that exact same coupling is the engine of departure. The moon's greatest contribution to life on Earth and its escape from Earth are the same force. Right now, as you watch this, Earth's rotation is measurably slower than it was 100 million years ago. When the first dinosaurs walked this planet, a day was approximately 23 hours long. When the first complex multicellular life emerged in the Cambrian, a day was 21 hours. Go back 1.4 billion years, and a day was 18 hours. The moon has been slowing Earth's rotation for its entire existence. In doing so, it has been continuously accelerating away. Earth's day is now 24 hours. In the far future, if Earth survives, tidal locking runs both ways. Earth would eventually show one face permanently to the moon, as the moon already shows one face permanently to Earth. At that endpoint, the recession stops. But we will never reach that endpoint. because in 600 million years, the eclipse threshold breaks first. And in approximately 1 billion years, the sun's increasing luminosity, it is already 30% brighter than at the formation of Earth, drives a runaway greenhouse effect that ends liquid water on this surface. The moon leaving is not the last threat. It is the one that arrives first. And here's what the eclipse threshold actually means in terms of orbital mechanics. Right now, the moon and the sun appear almost exactly the same angular size in Earth's sky. The sun is 400 times larger in diameter than the moon. The moon is 400 times closer to Earth than the sun. That ratio, a coincidence of orbital mechanics, a cosmic accident with no known physical law requiring it, produces the phenomenon of total solar eclipses. The moon's disk exactly covers the sun's photosphere, revealing the corona, the chromosphere, the solar prominences that are otherwise invisible. That ratio is already fracturing. The moon's apparent disk in our sky shrinks by a measurable angular value each year as it recedes. It is imperceptible to the human eye across a human lifetime. But across 600 million years, the geometry becomes terminal. The moon will no longer subtend a large enough angle to cover the solar disk. Total solar eclipses, the ones that stopped wars in the ancient world, that allowed Arthur Eddington in 1919 to confirm Einstein's theory of general relativity by photographing starlight bending around the sun during totality, that ancient civilizations across 6 continents built monuments to predict, become physically forbidden by orbital distance. Never again. Not rare. Not difficult to observe. Structurally impossible. Consider what the eclipse itself represents in human history. Every civilization that has ever existed on this surface has watched the same moon. The Babylonians built the Saros cycle, an 18-year, 11-day prediction system, to forecast eclipses with enough precision to awe their populations. The ancient Greeks used total solar eclipses to calculate Earth's circumference. Chinese astronomers documented them from 2000 BCE. The Maya encoded eclipse cycles into their calendar systems with mathematical precision that rivals modern computation. Every single one of those civilizations was looking at a moon that was already leaving. Every astronomer in every culture who ever traced the path of that disk across the sky was watching an object in an orbit that has never, in the history of this planet, been stable. It was always moving. It was always receding. The question was never if, only when. And when has already begun. The retroreflectors placed on the lunar surface during the Apollo missions in 1969 are not museum pieces. They are active scientific instruments. Right now, observatories around the world fire laser pulses at those mirrors and measure the return time to a precision of millimeters. That data has been collected continuously for over 50 years. The recession rate of 3.8 centimeters per year is not a model. It is not an extrapolation. It is a direct measurement, taken repeatedly, confirmed independently, published without dispute. NASA did not announce this with a press conference. There was no primetime broadcast, no international summit, just papers filed quietly. The data sits in open access archives that anyone can read, and almost no one does, because the implications are not the kind that fit into a news cycle. They are the kind that sit in the back of the mind and don't leave. But the eclipse is only the visible signal. The underlying damage runs deeper. The moon's gravitational stabilization of Earth's axial tilt is what separates this planet from Mars. Earth's tilt sits at 23.4 degrees and oscillates by only about 2.4 degrees over cycles of roughly 41,000 years. That narrow oscillation drives ice ages, shapes monsoons, determines which latitudes receive seasonal sunlight. But it remains within a range that life adapted to over hundreds of millions of years. Mars, with no large stabilizing moon, oscillates between 15 and 35 degrees of axial tilt over chaotic timescales. That instability is one reason Mars's surface is now a frozen desert blasted by ultraviolet radiation. As the moon recedes, its gravitational leverage on Earth's axis weakens, not catastrophically in a human lifetime, not in 1,000 human lifetimes, but across geological time, the stabilization degrades. Earth's tilt begins to wander beyond its current narrow band. Seasons deepen, polar ice expands and retreats in cycles more extreme than anything in the current geological record. The biological rhythms of every species that evolved in the current climatic regime begin to decouple from the environmental cues that shaped them. Every animal that reads a lunar cycle to time its breeding. Every species whose migration is calibrated to tidal cycles shaped by this specific moon at this specific distance. Every coral reef timed to spawn on the full moon of a particular month. They're all carrying a countdown in their biology. A countdown set by a moon that will no longer be where their ancestors needed it to be. And here's the final scale of what has already happened. Since the mass extinction event that ended the Cretaceous period, since the asteroid impact that incinerated the non-avian dinosaurs 66 million years ago, the moon has moved 14,000 miles farther away. You can hold that number in your mind, 14,000 miles. In the time since the last large animals that dominated this planet went extinct, the very object that stabilized the conditions for their successors has moved 14,000 miles toward the void. It is not returning. The same force that pulled the oceans into the tidal rhythms that coastal ecosystems evolved around. The same force that kept Earth's axis steady enough that complex multicellular life could persist for 600 million years. The same force that produced the exact coincidence of apparent sizes that allows total solar eclipses to exist is the force that is, right now, transferring angular momentum away from Earth and into the moon's escape trajectory. You are not observing a distant astronomical curiosity. You are living inside the system that is fracturing. The moon formed from this planet. It stabilized this planet. It made life on this planet possible. And it has been leaving since the moment the debris cloud that created it first began to coalesce. 4.5 billion years ago. 14,000 miles from where you now stand, under a sky where it still barely fits. 3.8 centimeters per year. 14,000 miles since the last mass extinction. 600 million years until the eclipses end forever. The moon created the conditions for everything alive on this planet, including you. And the same physics that made that possible has been writing the departure since the beginning. If the moon is the reason life emerged and persisted on Earth, and its departure is already confirmed, already measured, already locked into the orbital mechanics that cannot be reversed, what does that make every total solar eclipse still left for humanity to witness? Leave your answer below. Because whatever you believe, the universe is under no obligation to agree.